Question 1. The analysis reveals that when designing advanced microsegmentation strategies within a VMware NSX data center environment to enhance east-west traffic security, different approaches to policy implementation can yield vastly different operational and security outcomes. Considering the need for both robust security and application availability, which of the following implementation strategies is most aligned with best professional practices for advanced network design? Option A. Adopt the vendor's default security policy templates without customization or validation, assuming they provide adequate protection for all application workloads. Option B. Implement a phased rollout of microsegmentation policies, starting with critical applications and iteratively expanding based on traffic analysis and dependency mapping, ensuring policies are aligned with the principle of least privilege. Option C. Immediately deploy a blanket deny-all policy for all east-west traffic across the entire NSX environment to ensure maximum security from the outset. Option D. Focus exclusively on strengthening perimeter security controls and rely on existing network segmentation methods for internal traffic, bypassing granular microsegmentation for east-west flows. The correct answer is B. Implement a phased rollout of microsegmentation policies, starting with critical applications and iteratively expanding based on traffic analysis and dependency mapping, ensuring policies are aligned with the principle of least privilege. Explanation. The scenario presents a common challenge in advanced network design, balancing security posture with operational agility when implementing microsegmentation in a VMware NSX data center environment. The professional challenge lies in selecting a strategy that effectively enforces granular security policies without introducing undue complexity or hindering legitimate application traffic, all while adhering to the principles of least privilege and defense in depth, as mandated by general cybersecurity best practices, which are implicitly expected in advanced design certifications. Careful judgment is required to avoid overrestriction that cripples operations or underrestriction that leaves critical assets vulnerable. The correct approach, focusing on a phased, application-centric rollout of microsegmentation, represents best professional practice because it aligns with a risk-based security strategy. This method prioritizes critical applications and data, allowing for iterative refinement of security policies based on observed traffic patterns and application dependencies. This iterative process ensures that security controls are effective and do not negatively impact application performance or availability. It embodies the principle of start small, iterate, and scale, which is a cornerstone of successful complex technology deployments. This approach also facilitates better understanding and documentation of application communication flows, which is crucial for compliance and auditing purposes, indirectly supporting regulatory adherence by providing clear evidence of security controls. An incorrect approach that immediately attempts to implement a blanket deny-all policy for all east-west traffic without prior analysis is professionally unacceptable. This failure stems from a lack of due diligence and a disregard for application dependencies. Such an approach would likely lead to widespread service disruptions, impacting business operations and potentially violating service-level agreements, SLAs. Ethically, it demonstrates a failure to adequately assess risks and impacts before implementing changes, leading to unintended negative consequences for the organization. Another incorrect approach, focusing solely on perimeter security and neglecting east-west traffic, represents a significant security gap. This is a failure to implement a defense-in-depth strategy, leaving the internal network vulnerable to lateral movement by threats that breach the perimeter. This is a direct contravention of modern cybersecurity principles and would be considered a failure to meet industry standards for advanced network security design. It also fails to leverage the capabilities of NSX for granular internal segmentation, a key benefit of the technology. Finally, an approach that relies solely on vendor-provided default security policies without customization or validation is also professionally unsound. While vendor defaults can provide a baseline, they are rarely optimized for a specific organization's unique application landscape and threat profile. This approach risks either being too permissive, leaving vulnerabilities unaddressed, or too restrictive, causing operational issues. It demonstrates a lack of ownership and a failure to tailor security solutions to the specific needs and risks of the environment, which is a fundamental aspect of professional responsibility in advanced design. The professional reasoning process for such situations involves a structured approach. First, understand the business objectives and critical assets. Second, conduct a thorough assessment of application communication patterns and dependencies. Third, design security policies based on the principle of least privilege, starting with a baseline and iteratively refining. Fourth, implement changes in a phased manner, with robust monitoring and rollback plans. Finally, continuously review and adapt security policies based on evolving threats and business needs. Question 2. The audit findings indicate a potential misconfiguration in the NSX distributed firewall rules that could allow for unauthorized lateral movement of threats within the data center. Which of the following approaches best addresses this finding while adhering to best practices for advanced NSX design and security? Option A. Implement a blanket rule to allow all traffic between segments until the misconfiguration can be investigated at a later date. Option B. Review and refine existing distributed firewall rules and security group memberships to ensure they enforce the principle of least privilege and align with the documented network segmentation strategy. Option C. Immediately disable the distributed firewall for the affected segments to prevent any potential misconfigurations from impacting network traffic. Option D. Remove all custom security groups and revert to default firewall policies to simplify management and eliminate potential errors. Correct answer is B. Review and refine existing distributed firewall rules and security group memberships to ensure they enforce the principle of least privilege and align with the documented network segmentation strategy. Explanation. This scenario presents a professional challenge due to the critical nature of network security and the potential for significant business disruption and data compromise if security controls are not adequately implemented and validated. The audit findings highlight a gap in the assurance of security posture, requiring a careful and informed decision on how to address the identified vulnerabilities. The core of the challenge lies in balancing the need for immediate remediation with the long-term strategic goals of security architecture and compliance. The correct approach represents best professional practice because it prioritizes a comprehensive and validated understanding of the security posture before implementing changes. This aligns with the principles of secure design and operation, ensuring that any remediation efforts are targeted, effective, and do not introduce new risks. Specifically, in the context of VMware NSX Data Center Advanced Design, this involves a deep dive into the configuration and operational aspects of distributed firewall rules, security groups, and micro-segmentation policies. This methodical approach ensures that the remediation directly addresses the root cause of the audit finding and adheres to the principle of least privilege, a fundamental tenet of cybersecurity. It also allows for the verification of compliance with internal security policies and any relevant industry standards or regulatory requirements that might be applicable to the organization's data handling practices. An incorrect approach that focuses solely on disabling security features to resolve audit findings is professionally unacceptable. This represents a failure to uphold the organization's security objectives and a disregard for the potential consequences of weakened security. Such an action would likely violate internal security policies and could expose the organization to significant risks, including data breaches, unauthorized access, and service disruptions. Ethically, it demonstrates a lack of due diligence and a prioritization of short-term expediency over long-term security and integrity. Another incorrect approach, which involves implementing broad, unvalidated changes to security policies without a clear understanding of their impact, is also professionally unsound. This can lead to unintended consequences, such as blocking legitimate traffic, disrupting critical business operations, and creating new security vulnerabilities. This approach lacks the rigor required for effective security management and fails to demonstrate a commitment to a secure and stable network environment. It also bypasses the necessary validation steps that ensure security controls are functioning as intended and are aligned with business requirements. The professional reasoning process for this situation should involve a structured approach to risk management and problem solving. First, thoroughly investigate the audit findings to understand the specific nature and impact of the identified vulnerabilities. Second, consult relevant documentation, including NSX design guides, security policies, and any applicable regulatory frameworks. Third, Develop a remediation plan that addresses the root cause, prioritizes actions based on risk, and includes clear validation steps. Fourth, implement the remediation plan in a controlled manner, ideally in a test environment or during a scheduled maintenance window, with rollback procedures in place. Finally, conduct post-remediation validation and testing to confirm the effectiveness of the changes and ensure that no new issues have been introduced. This systematic process ensures that security decisions are informed, effective, and aligned with organizational objectives. Question 3. Compliance review shows that the organization handles sensitive customer data that falls under strict data protection regulations. The advanced design of the VMware NSX data center environment must ensure that this sensitive data is adequately protected and that access is strictly controlled according to these regulations. Which of the following design approaches best aligns with both the advanced capabilities of NSX and the regulatory requirements for data protection? Option A. Design NSX network segments based solely on application communication flows, assuming that controlling application traffic will inherently satisfy data protection regulations. Option B. Configure NSX with a default, allow security policy for all traffic within the data center, with minimal segmentation applied only to critical infrastructure. Option C. Deploy a traditional perimeter firewall in front of the NSX environment and rely on broad network segmentation without specific data classification considerations within NSX. Option D. Implement microsegmentation policies in NSX that strictly isolate workloads processing sensitive data, applying granular firewall rules based on data classification and regulatory mandates, and enforcing a default deny posture for all intersegment traffic. The correct answer is D. Implement microsegmentation policies in NSX that strictly isolate workloads processing sensitive data, applying granular firewall rules based on data classification and regulatory mandates, and enforcing a default deny posture for all intersegment traffic. Explanation. Scenario analysis. This scenario presents a professional challenge in designing a secure and compliant network architecture within the specific regulatory framework governing the exam's jurisdiction. The core difficulty lies in balancing the technical requirements of advanced NSX data center design, such as microsegmentation and distributed firewalling, with the stringent mandates of data protection and network security regulations. Misinterpreting or inadequately implementing these regulations can lead to significant compliance failures, data breaches, and reputational damage. The need for a deep understanding of both NSX capabilities and the applicable regulatory landscape is paramount. Correct approach analysis. The correct approach involves a comprehensive assessment of the regulatory requirements for data classification and handling, and then mapping these requirements directly to NSX's microsegmentation capabilities. This ensures that sensitive data is isolated and protected according to legal mandates, and that access controls are granular and enforced at the workload level. This approach represents best professional practice because it proactively embeds compliance into the design phase, rather than attempting to retrofit it later. It aligns with the principle of security by design and demonstrates due diligence in protecting regulated data, thereby meeting the spirit and letter of the law. Incorrect approach is analysis. Implementing a broad, perimeter-based firewalling strategy without leveraging NSX's microsegmentation fails to address the specific regulatory requirements for granular data protection and workload isolation. This approach is professionally unacceptable because it ignores the advanced security capabilities of NSX and creates a false sense of security, leaving sensitive data vulnerable to lateral movement within the network. It is a direct violation of regulations that mandate specific controls for different data classifications. Designing the network solely based on application communication flows without explicit consideration of data classification and regulatory mandates is also professionally unacceptable. While understanding communication flows is crucial for network performance, it does not inherently guarantee compliance with data protection laws. This approach risks overlooking critical security controls required for sensitive data, leading to regulatory noncompliance and potential data breaches. Adopting a default allow security posture within NSX, even with some segmentation, is a significant regulatory and ethical failure. Many regulations require a default deny or least privilege approach for accessing sensitive data. A default allow posture, even if partially segmented, increases the attack surface and makes it difficult to demonstrate compliance with access control requirements, exposing the organization to severe penalties. Professional reasoning. Professionals tasked with advanced NSX design must adopt a risk-based approach that prioritizes regulatory compliance. This involves 1. Thoroughly understanding the specific regulatory framework applicable to the organization's data and operations. 2. Identifying data classifications and their associated protection requirements as mandated by law. 3. Mapping these regulatory requirements to the advanced security features of NSX, particularly microsegmentation and distributed firewalling. 4. Designing the NSX environment to enforce granular access controls and isolation based on data classification and regulatory mandates. 5. Regularly reviewing and auditing the NSX configuration against regulatory requirements and evolving threats. Question 4. During the evaluation of a new multi-cloud strategy requiring advanced network virtualization and security segmentation for sensitive customer data, which NSX data center design approach best aligns with the stringent data protection and network security requirements mandated by U.S. federal regulations, while also ensuring operational manageability and auditability across distributed environments? Option A. Rely on native cloud provider security controls and on-premises firewall appliances for segmentation and threat prevention, with NSX primarily used for basic network connectivity and overlay networking. Option B. Implement a centralized NSX manager cluster to define and enforce security policies, leveraging distributed firewall rules and security groups applied consistently across on-premises and cloud deployments, with a focus on unified policy management and auditing. Option C. Deploy NSX in a fully decentralized model, with each workload or application team managing its own security policies and firewall rules independently, without a central policy aggregation or reporting mechanism. Option D. Focus solely on network segmentation using NSX segments and logical routers, deferring advanced security services like intrusion detection and prevention to separate non-integrated security solutions. The correct answer is B. Implement a centralized NSX manager cluster to define and enforce security policies, leveraging distributed firewall rules and security groups applied consistently across on-premises and cloud deployments, with a focus on unified policy management and auditing. Explanation. The scenario presents a common challenge in advanced network design, balancing the need for robust security segmentation with the operational complexities of managing distributed security policies across a multi-cloud environment. The professional challenge lies in selecting an NSX design that not only meets the technical requirements for microsegmentation and threat prevention, but also aligns with the organization's governance, compliance, and operational capabilities. This requires a deep understanding of NSX's capabilities in relation to the specific regulatory framework governing the organization's operations, which in this context is assumed to be aligned with U.S. federal regulations for data protection and network security. The correct approach emphasizes a centralized management plane for policy definition and enforcement, leveraging NSX's distributed firewall and security groups. This aligns with best professional practice by ensuring consistent security posture across all deployed environments, simplifying auditing, and facilitating rapid response to security incidents. It adheres to the principle of least privilege and defense in depth, which are foundational to U.S. federal data protection mandates. Centralized policy management reduces the risk of misconfiguration and ensures that security controls are applied uniformly, thereby meeting compliance requirements for data segregation and access control. An incorrect approach that relies on disparate, on-premises firewall rules and manual configuration for cloud workloads fails to leverage the inherent capabilities of NSX for automated and consistent policy enforcement. This introduces significant security gaps and compliance risks. Specifically, it violates the principle of unified security management, making it difficult to audit and prove compliance with regulations, requiring consistent security controls across all data processing environments. It also increases the likelihood of human error, leading to unauthorized access or data breaches, which are direct violations of data protection laws. Another incorrect approach that focuses solely on network segmentation without integrating threat intelligence and advanced security services, like ID/IPS, overlooks the evolving threat landscape and the comprehensive security requirements mandated by many U.S. federal regulations. While segmentation is crucial, it is only one layer of defense. Failing to implement advanced threat detection and prevention mechanisms leaves the environment vulnerable to sophisticated attacks that can bypass basic network controls. This approach is professionally deficient as it does not provide a holistic security solution, potentially leading to non-compliance with regulations that require proactive threat mitigation. A third incorrect approach that prioritizes a purely decentralized, workload-native security model without a unifying management layer, while offering granular control, can lead to policy sprawl and management overhead. This can make it challenging to maintain a consistent security posture and demonstrate compliance across the entire organization. Without a centralized view and control mechanism, it becomes difficult to enforce organizational security standards uniformly and to respond effectively to enterprise-wide security incidents, potentially leading to regulatory scrutiny. The professional decision-making process should involve a thorough assessment of the organization's specific security and compliance obligations, an in-depth understanding of NSX's architecture and capabilities, and a realistic evaluation of operational resources. The chosen design must prioritize a unified and auditable security framework that can adapt to evolving threats and regulatory landscapes, ensuring both technical efficacy and compliance adherence. Question 5. Benchmark analysis indicates that a financial services organization in the United States is migrating its core trading platform to a VMware NSX data center environment. The primary regulatory concerns for this organization revolve around data confidentiality, integrity, and availability, as mandated by U.S. financial sector regulations. Which design approach best aligns with these regulatory imperatives and demonstrates a robust security posture? Option A. Focus primarily on strengthening the perimeter firewall and intrusion prevention system (IPS) at the network edge, assuming that internal network traffic is inherently more trusted and requires less granular security. Option B. Implement comprehensive microsegmentation policies within NSX to isolate critical trading data and applications, coupled with robust logging and auditing of all network traffic and security events, and integrate with security information and event management (SIEM) tools for continuous monitoring and compliance reporting. Option C. Utilize NSX's advanced routing and load balancing features to optimize application delivery, with security being a secondary consideration addressed through Basic Network Access Control Lists (ACL), applied broadly across segments. Option D. Deploy NSX with minimal security configurations, prioritizing maximum network performance and agility, with the understanding that security can be addressed through separate, ad hoc security solutions if specific threats emerge. The correct answer is B. Implement comprehensive microsegmentation policies within NSX to isolate critical trading data and applications, coupled with robust logging and auditing of all network traffic and security events, and integrate with security information and event management (SIEM) tools for continuous monitoring and compliance reporting. Explanation: this scenario presents a professional challenge in designing a secure and compliant network architecture for a financial services organization operating within the United States, specifically adhering to the regulatory framework relevant to the 3V0-4220 Advanced Design VMware NSX Data Center exam. The core challenge lies in balancing the advanced networking capabilities of NSX with the stringent data protection and privacy requirements mandated by U.S. financial regulations, such as those enforced by the Securities and Exchange Commission (SEC) and the Office of the Comptroller of the Currency (OCC). Organizations in this sector are under intense scrutiny to prevent data breaches, ensure system availability, and maintain the integrity of financial transactions. Therefore, any design decision must demonstrably support these regulatory objectives. The correct approach represents best professional practice because it prioritizes a defense-in-depth strategy that is explicitly aligned with regulatory expectations for data security and resilience. By leveraging NSX's microsegmentation capabilities to enforce granular access controls and isolate sensitive data, and by integrating with established security monitoring tools for real-time threat detection and compliance reporting, the design directly addresses the core tenets of U.S. financial regulations. This proactive and layered security posture minimizes the attack surface and provides auditable evidence of compliance, which is critical during regulatory examinations. An incorrect approach that relies solely on perimeter security without granular internal controls fails to meet regulatory expectations for data protection. U.S. financial regulations emphasize the need to protect sensitive customer data wherever it resides within the network, not just at the edge. Such an approach would be considered a significant regulatory failure, as it leaves critical internal assets vulnerable to lateral movement by attackers who breach the perimeter. Another incorrect approach that neglects robust logging and auditing mechanisms would also be a regulatory failure. Compliance mandates require organizations to be able to demonstrate their security controls and incident response capabilities through comprehensive audit trails. Without these, an organization cannot prove adherence to security standards or effectively investigate security incidents, leading to potential penalties. A third incorrect approach that prioritizes performance over security without a clear risk assessment and documented justification would be ethically questionable and likely non-compliant. While performance is important, it cannot come at the expense of fundamental security requirements mandated by regulators, especially in the financial sector. The professional decision-making process for similar situations should involve a thorough understanding of the applicable regulatory landscape, a comprehensive risk assessment of the proposed design, and a clear articulation of how each design element contributes to meeting compliance objectives. Professionals must engage in a continuous dialogue with legal and compliance teams to ensure the design aligns with evolving regulatory requirements. The focus should always be on building security and compliance into the architecture from the outset, rather than attempting to retrofit it later. Question 6. The assessment process reveals a need to implement granular security policies across a multi-cloud NSX data center deployment. The design team is debating the most effective method for enforcing these policies to ensure both robust security and operational efficiency. Considering the inherent architecture of NSX and the need for consistent policy application across diverse workloads, which approach to security policy enforcement is most aligned with best professional practices and regulatory expectations for advanced network design. Option A. Implement security policies primarily through distributed firewall rules applied directly to virtual machines and workloads, leveraging NSX's native microsegmentation capabilities. Option B. Adopt a hybrid approach where security policies are enforced inconsistently across different network segments, mixing distributed and centralized methods without a defined strategy. Option C. Focus solely on configuring NSX edge firewall rules for all security policy enforcement, neglecting the capabilities of the distributed firewall. Option D. Rely on a single, centralized firewall appliance at the network edge to inspect and enforce all security policies for the entire NSX environment. Correct answer is A. Implement security policies primarily through distributed firewall rules applied directly to virtual machines and workloads, leveraging NSX's native microsegmentation capabilities. Explanation. The assessment process reveals a common challenge in advanced network design, balancing the need for robust security segmentation with the operational complexities of managing distributed security policies. In the context of VMware NSX data center, this often translates to deciding between a centralized and a decentralized approach to security policy enforcement. The professional challenge lies in understanding the implications of each approach on scalability, performance, compliance, and manageability, especially within a regulated environment where auditability and consistent policy application are paramount. The correct approach, which involves a distributed enforcement model for security policies, represents best professional practice because it aligns with the inherent architecture of NSX. NSX's distributed firewall, DFW, is designed to enforce policies at the virtual machine, VM, or workload level, regardless of their physical location or network topology. This distributed enforcement ensures that security policies are applied as close to the protected resource as possible, minimizing the attack surface and improving security posture. From a compliance perspective, this granular enforcement simplifies auditing by providing clear visibility into policy application at the individual workload level, which is often a requirement in regulated industries. It also enhances agility, allowing security policies to move with the workloads, a critical factor in dynamic cloud-native environments. An incorrect approach would be to rely solely on a centralized enforcement point for all security policies. This fails to leverage the capabilities of NSX's DFW and introduces a potential bottleneck. In a distributed environment, a centralized enforcement point would require all traffic to traverse a single security appliance or gateway, negating the benefits of microsegmentation and increasing latency. From a regulatory standpoint, this approach can lead to challenges in demonstrating compliance with granular security requirements, as it may obscure the actual enforcement points for specific workloads. It also presents a single point of failure and a concentrated target for attacks, which is unacceptable in a secure design. Another incorrect approach would be to implement security policies inconsistently across different segments of the NSXT environment. For example, using DFW for some segments and edge firewall rules for others without a clear architectural rationale. This inconsistency creates security gaps and makes auditing and troubleshooting significantly more difficult. It violates the principle of least privilege and can lead to unintended policy bypasses, which are serious regulatory and ethical failures, particularly in environments subject to data protection regulations. The professional decision-making process for similar situations should involve a thorough understanding of the NSXT architecture and its security enforcement mechanisms. It requires evaluating the specific security and compliance requirements of the organization, considering factors such as workload mobility, performance needs, and operational overhead. A risk-based approach, prioritizing the protection of critical assets and sensitive data, should guide the design. Furthermore, continuous monitoring and auditing capabilities must be integrated into the design to ensure ongoing compliance and effective security posture management. Question 7. Regulatory review indicates that a financial services organization in the United States is designing a new data center network utilizing VMware NSXT data center. The organization handles sensitive customer financial data and must comply with SEC regulations and PCI DSS. Which of the following design approaches best aligns with these regulatory mandates for data protection and network security? Option A. Rely primarily on traditional perimeter firewalls and assume NSXT's advanced features are secondary for compliance purposes. Option B. Deploy NSXT microsegmentation without a documented policy framework or clear audit procedures. Option C. Disable or minimize NSXT's logging and auditing features to reduce operational overhead and complexity. Option D. Implement NSXT microsegmentation to enforce granular security policies at the workload level, coupled with centralized logging and monitoring for audit trails. The correct answer is D. Implement NSXT microsegmentation to enforce granular security policies at the workload level, coupled with centralized logging and monitoring for audit trails. Explanation. Scenario analysis. This scenario presents a professional challenge in designing a secure and compliant network architecture for a financial services organization operating within the United States. The core difficulty lies in balancing the advanced security capabilities of VMware NSXT data center with the stringent regulatory requirements mandated by the U.S. Securities and Exchange Commission, SEC, and the Payment Card Industry Data Security Standard, PCI DSS. Specifically, the organization must ensure that its data center network design adheres to principles of least privilege, robust access control, and comprehensive logging, all while maintaining operational efficiency and scalability. Pressure to implement cutting-edge technology without compromising compliance creates a complex decision-making environment. Correct approach analysis. The correct approach involves leveraging NSXT's microsegmentation capabilities to enforce granular security policies at the workload level, aligning directly with the SEC's focus on protecting sensitive financial data and the PCI DSS requirement for protecting cardholder data. Implementing distributed firewall rules that restrict east-west traffic between applications and services based on the principle of least privilege is paramount. This ensures that only authorized communication paths are permitted, significantly reducing the attack surface. Furthermore, integrating NSXT with centralized logging and monitoring solutions, such as SIEM systems, is crucial for meeting regulatory mandates for audit trails and incident response. This approach demonstrates best professional practice by proactively embedding security and compliance into the network design, rather than attempting to retrofit it later. It directly addresses the spirit and letter of regulations, like the SEC's Regulation SB, Privacy of Consumer Financial Information, and the PCI DSS requirement for network segmentation and access control. Incorrect approach is analysis. One incorrect approach would be to rely solely on perimeter security, e.g., traditional firewalls at the network edge, and assume that NSX's advanced features are not strictly necessary for compliance. This fails to meet the regulatory expectation for defense in depth and granular control, particularly for internal threats or compromised workloads. SEC and PCI DSS emphasize protecting data at its source, which perimeter security alone cannot achieve. This approach represents a significant regulatory failure by neglecting the principle of least privilege within the data center and failing to adequately segment sensitive data. Another incorrect approach would be to implement microsegmentation without a clear policy framework or proper documentation. While technically implementing the feature, the lack of a defined strategy and auditable policies would render it ineffective from a compliance perspective. Regulators require demonstrable adherence to security policies, not just the deployment of security tools. This approach fails ethically and regulatorily by not providing the necessary evidence of compliance, and by creating an environment where security controls are not consistently applied or understood, leading to potential gaps and misconfigurations. A third incorrect approach would be to disable or inadequately configure NSX's logging and auditing capabilities to reduce operational overhead. This directly contravenes SEC and PCI DSS requirements for comprehensive logging and monitoring of network activity. The inability to provide audit trails for security events, access attempts, or policy changes would be a critical regulatory failure, hindering investigations and demonstrating a lack of due diligence in protecting sensitive information. Professional reasoning. Professionals must adopt a risk-based approach, prioritizing regulatory compliance as a foundational element of network design. This involves thoroughly understanding the specific requirements of applicable regulations, e.g., SEC rules, PCI DSS, and mapping them to the capabilities of technologies like NSXT. The decision-making process should involve a collaborative effort between network architects, security engineers, and compliance officers. When evaluating design choices, professionals should ask, does this design element directly support a specific regulatory requirement? And can we demonstrate compliance with this design? The focus should always be on proactive security and compliance integration, ensuring that the chosen architecture is not only technically sound, but also demonstrably compliant and auditable. Question 8. Strategic planning requires a careful balance between rapid deployment and robust security. An advanced NSXT data center designer is tasked with implementing a new network segmentation strategy. During the design review, a senior stakeholder expresses urgency, suggesting a simplified approach that bypasses some of the more complex, but security-enhancing, micro-segmentation policies to accelerate the rollout. The designer recognizes that this shortcut could introduce significant security risks and potential compliance issues. What is the most ethically and professionally responsible course of action for the advanced designer? Option A. Refuse to implement any design that deviates from the most secure and complex configuration, regardless of the stakeholder's urgency or business needs. Option B. Advocate for a phased rollout, implementing the core segmentation first, and then addressing the more complex security policies in a subsequent, but timely, phase, while clearly documenting the risks of the initial simplified deployment. Option C. Proceed with the simplified design as requested by the senior stakeholder to meet the urgent deployment deadline, assuming security risks can be mitigated later. Option D. Implement the simplified design and immediately escalate concerns about the security risks to the compliance department, without further discussion with the stakeholder. Correct answer is B. Advocate for a phased rollout, implementing the core segmentation first, and then addressing the more complex security policies in a subsequent, but timely phase, while clearly documenting the risks of the initial simplified deployment. Explanation. Scenario analysis. This scenario presents a common ethical dilemma in IT design and implementation, particularly within regulated environments. The challenge lies in balancing the immediate business need for rapid deployment with the long-term security and compliance requirements mandated by VMware NSX data center, best practices, and potential regulatory frameworks that might govern data handling and network security. The pressure to deliver a solution quickly can lead to shortcuts that compromise security posture, potentially exposing the organization to significant risks, including data breaches, non-compliance penalties, and reputational damage. The ethical responsibility of the advanced designer is to advocate for a secure and compliant design, even when faced with pressure for expediency. Correct approach analysis. The correct approach prioritizes a thorough security design review and adherence to established NSX best practices before proceeding with deployment. This aligns with the ethical obligation of an IT professional to act in the best interest of their organization and its stakeholders, which includes protecting sensitive data and maintaining operational integrity. In the context of VMware NSX data center, this means ensuring that the design incorporates robust security controls, micro-segmentation, and appropriate network policies from the outset. This proactive stance prevents the introduction of vulnerabilities and ensures compliance with any relevant industry standards or regulations that dictate network security and data protection. It demonstrates professional integrity by refusing to compromise on security for the sake of speed. Incorrect approaches analysis. Proceeding with deployment without a comprehensive security review and validation against NSX best practices is ethically unsound and professionally negligent. This approach risks introducing security gaps that could be exploited, leading to data breaches or unauthorized access. Such an action would violate the principle of due diligence and could result in significant financial and reputational damage to the organization, as well as potential legal repercussions if regulatory noncompliance occurs. Implementing a design that prioritizes ease of management over security controls, even if it appears to meet immediate functional requirements, is also an ethical failure. Security should not be an afterthought. This approach neglects the fundamental responsibility to protect the network and the data it carries, potentially creating a false sense of security while leaving critical vulnerabilities unaddressed. This could lead to noncompliance with data protection regulations and a compromised security posture. Accepting the proposed design without questioning its security implications or seeking expert consultation simply because it was presented by a senior stakeholder demonstrates a lack of professional courage and ethical responsibility. An advanced designer has a duty to challenge designs that appear inadequate or risky, regardless of the source. This passive acceptance can lead to the deployment of insecure infrastructure, directly contravening the professional obligation to ensure the integrity and security of the IT environment. Professional reasoning. Professionals facing such situations should employ a structured decision-making process. First, clearly identify the ethical and professional obligations, which in this case involve ensuring security and compliance. Second, assess the risks associated with each potential course of action. Third, consult relevant documentation, best practices, like VMware NSX design guides, and potentially internal or external compliance experts. Fourth, communicate the risks and recommended secure approach clearly and professionally to stakeholders, providing data-driven justifications. Finally, stand firm on ethical principles, advocating for the secure and compliant solution, even if it requires additional time or resources. The ultimate goal is to protect the organization's assets and reputation. Question 9. Market research demonstrates a growing need for enhanced security segmentation within enterprise data centers to mitigate advanced persistent threats and comply with evolving data protection standards. A financial services organization is implementing VMware NSX data center and requires a micro-segmentation strategy for a critical multi-tier trading application. The primary goal is to restrict communication between application tiers and individual services to only what is absolutely necessary, thereby minimizing the attack surface and preventing unauthorized data access. The organization has a mature security team but limited resources for extensive manual policy creation and management. Which of the following approaches best addresses the organization's requirements for advanced microsegmentation using NSX data center? Option A. Implement a perimeter-based security model using traditional network firewalls at the edge of the data center, supplemented by basic NSX firewall rules for interVLAN traffic. Option B. Utilize NSX's distributed firewall to create granular security policies based on application identity and observe traffic flows, leveraging NSXT's automation capabilities for policy deployment and management. Option C. Configure host-based firewalls on each virtual machine within the application tiers and rely on these for all microsegmentation enforcement, with NSXT primarily used for network virtualization. Option D. Apply a default deny all policy across all NSXT segments and then manually create explicit allow rules for every single network connection required by the application. The correct answer is B. Utilize NSXT's distributed firewall to create granular security policies based on application identity and observe traffic flows, leveraging NSXT's automation capabilities for policy deployment and management. Explanation: scenario analysis. This scenario presents a common challenge in advanced network design, balancing the need for robust security segmentation with the operational complexities and potential performance impacts of microsegmentation. The professional challenge lies in designing a solution that meets stringent security requirements, as mandated by industry best practices and potential regulatory compliance. Though specific regulations are not detailed here, the implication is a need for secure data handling, without introducing undue complexity or negatively affecting application performance. The decision requires a deep understanding of NSXT's capabilities, the application's communication patterns, and the organization's risk tolerance. Correct approach analysis. The correct approach leverages NSXT's distributed firewall capabilities to implement microsegmentation based on application identity and communication flows. This aligns with modern security paradigms that assume a breach and focus on limiting lateral movement. By analyzing application traffic patterns and defining security policies that allow only necessary communication between application tiers and components, the solution minimizes the attack surface. This approach is best professional practice because it provides granular security, enhances compliance posture by isolating sensitive data, and is designed to be scalable and manageable within the NSXT framework. It directly addresses the security mandate while acknowledging the need for operational feasibility. Incorrect approaches analysis. Implementing microsegmentation solely at the network perimeter with traditional firewalls fails to address the internal threat landscape and lateral movement, a critical gap in modern security. This approach is professionally unacceptable as it does not meet the advanced security requirements implied by the need for microsegmentation within the data center. Applying a blanket, deny all policy without careful analysis of application communication flows would lead to significant operational disruption and application outages. While seemingly secure, it is professionally irresponsible due to its impracticality and failure to consider the functional requirements of the business. This approach ignores the principle of least privilege in a way that cripples operations, relying exclusively on host-based firewalls, while a component of defense in depth is insufficient for comprehensive microsegmentation at the data center level. It lacks centralized management, visibility, and the advanced policy enforcement capabilities that NSXT provides, making it difficult to maintain and audit across a large environment. This approach is professionally inadequate as it does not leverage the full potential of the chosen platform for advanced security design. Professional reasoning. Professionals should approach such design challenges by first thoroughly understanding the security objectives and any relevant compliance mandates. This is followed by a deep dive into the application architecture and its communication requirements. The next step involves evaluating the capabilities of the chosen technology, NSXT in this case, to meet these requirements effectively and efficiently. A phased implementation approach, starting with less critical applications and iteratively refining policies based on monitoring and feedback, is crucial for minimizing risk and ensuring operational stability. Continuous monitoring and adaptation of security policies are essential to maintain effectiveness. Question 10. Implementation of a new NSXT data center deployment for a multi-tier financial application requires strict isolation of the database tier, which contains sensitive customer financial data, from all other tiers. The application is deployed across multiple XC hosts and is expected to scale dynamically. The design must ensure that only authorized application servers can communicate with the database servers on the specific port required for data access, while all other inbound and outbound traffic to the database tier is blocked. Option A. Configure NSXT distributed firewall rules to allow traffic from a security group containing the application servers to the security group containing the database servers on the required database port. Implement a default rule to deny all other traffic to the database tier. Option B. Create static NSX distributed firewall rules based on the current IP addresses of the database servers and application servers, allowing communication on the database port, and rely on manual updates as IP addresses change. Option C. Configure NSX distributed firewall rules to allow all traffic from any source to the IP addresses of the database servers on the required database port, and then implement a default rule to deny all other traffic. Option D. Implement a single gateway firewall rule at the edge of the NSX environment to block all inbound traffic to the IP address range of the database servers, except for the specific database port from any source. The correct answer is A. Configure NSX distributed firewall rules to allow traffic from a security group containing the application servers to the security group containing the database servers on the required database port. Implement a default rule to deny all other traffic to the database tier. Explanation. Scenario analysis. This scenario presents a common challenge in advanced network design, balancing the need for robust security segmentation with the operational complexities of managing distributed workloads. The core difficulty lies in ensuring that the NSX data center deployment adheres to the principle of least privilege and effectively isolates sensitive data and applications, while simultaneously enabling necessary intersegment communication for legitimate business functions. The challenge is amplified by the dynamic nature of cloud-native environments, where workloads can be ephemeral and distributed across multiple hosts and availability zones. Misconfigurations can lead to significant security vulnerabilities or operational disruptions, requiring a deep understanding of NSX's capabilities and their implications for compliance and business continuity. Correct approach analysis. The correct approach involves leveraging NSX's distributed firewall, DFW, capabilities to enforce microsegmentation policies based on logical constructs like security groups and tags. This aligns with best practices for modern security architectures, emphasizing a zero-trust model where no traffic is implicitly trusted. By defining policies that explicitly allow necessary communication between specific application tiers or services, while denying all other traffic by default, the design ensures that sensitive data remains isolated. This granular control is crucial for meeting regulatory compliance requirements that mandate data protection and access control, such as those that might be stipulated by a hypothetical regulatory body governing data handling within the organization's operational jurisdiction. The use of logical constructs simplifies policy management and ensures that policies follow workloads as they move, reducing the risk of misconfiguration and enhancing agility. Incorrect approaches analysis. One incorrect approach would be to rely solely on gateway firewall rules at the edge of the network to segment traffic. This is insufficient because it provides macro-segmentation rather than micro-segmentation. It fails to protect against lateral movement of threats within the data center, leaving internal segments vulnerable if an attacker breaches the perimeter. This approach would likely violate regulatory mandates that require granular control over data access and protection within the internal network. Another incorrect approach is to implement overly broad, allow all rules within the DFW to simplify initial deployment. This directly contradicts the principle of least privilege and creates significant security gaps. It would expose sensitive applications and data to unnecessary risks, making it difficult to demonstrate compliance with security standards that require strict access controls and audit trails. Such a configuration would be a clear failure to implement adequate security measures as expected by any governing framework. A third incorrect approach is to configure DFW rules based solely on IP addresses without utilizing security groups or tags. While IP-based rules can work in static environments, they become unmanageable and error-prone in dynamic, cloud-native deployments, where IP addresses can change frequently. This lack of dynamic policy enforcement increases the risk of misconfiguration, leading to either security breaches or unintended service disruptions. From a compliance perspective, relying on brittle, static configurations makes it challenging to prove continuous adherence to security policies. Professional reasoning. Professionals should approach this scenario by first understanding the specific data sensitivity and application communication requirements. This involves engaging with application owners and security teams to map out necessary traffic flows. The next step is to translate these requirements into NSX DFW policies, prioritizing the use of security groups and tags for dynamic policy assignment. A deny by default posture should be enforced, with explicit allow rules for only the essential communication paths. Regular auditing and testing of these policies are critical to ensure their continued effectiveness and compliance with any applicable regulatory standards. This systematic, security-first approach, combined with an understanding of the technology's capabilities for dynamic policy enforcement, forms the basis of professional decision-making in such advanced network design scenarios. Question 11. The monitoring system demonstrates a sudden, significant increase in east-west traffic between two specific virtual machines within a critical application segment, accompanied by a single, low-severity alert for unusual protocol usage on one of the VMs. The network administrator needs to determine the most appropriate immediate course of action. Option A. Initiate a full network scan of the affected segment to identify any potential vulnerabilities. Option B. Correlate the traffic spike and alert with other security monitoring tools and analyze NSX flow logs for the affected VMs to understand the traffic's nature before taking action. Option C. Ignore the alert as it is low severity and the traffic increase might be a legitimate application behavior. Option D. Immediately isolate the virtual machine exhibiting the unusual protocol usage to prevent potential lateral movement. Correct answer is D. Immediately isolate the virtual machine exhibiting the unusual protocol usage to prevent potential lateral movement. Explanation. This scenario presents a professional challenge due to the critical nature of network security and the potential for misinterpretation of monitoring alerts. The core difficulty lies in distinguishing between a genuine security incident requiring immediate, potentially disruptive action and a transient anomaly that might be resolved through less intrusive means. The need for rapid, accurate assessment is paramount to maintain service availability while safeguarding against threats, all within the operational and security guidelines of a VMware NSX data center environment. The correct approach represents best professional practice because it prioritizes a systematic, evidence-based investigation before escalating to potentially disruptive actions. This aligns with the principles of responsible incident response, which emphasizes verification and containment. By correlating alerts with other security tools and analyzing traffic patterns, the network administrator can build a comprehensive understanding of the situation. This methodical process minimizes the risk of false positives leading to unnecessary downtime or resource expenditure, thereby upholding operational integrity and compliance with internal security policies that mandate thorough investigation of security events. An incorrect approach that immediately isolates a segment based solely on a single alert fails to adhere to due diligence. This could lead to a denial of service for legitimate users or applications, causing significant business impact. Ethically and professionally, such an action is premature and could be construed as negligent if not properly investigated. Another incorrect approach, which involves ignoring the alert due to its perceived low severity, is equally problematic. This neglects the fundamental responsibility to investigate all security-related events, regardless of initial perceived impact. A seemingly minor anomaly could be an indicator of a more sophisticated, low and slow attack. Failing to investigate violates the principle of proactive security and could expose the organization to significant risk, potentially breaching compliance requirements related to security monitoring and incident response. The professional decision-making process should involve a tiered response strategy. First, acknowledge and log the alert. Second, gather contextual information from multiple sources, including NSX logs, firewall logs, IDS/IPS alerts, and application logs. Third, analyze the correlated data to identify patterns and confirm the nature of the event. Fourth, based on the confirmed threat level, implement appropriate containment and remediation actions, which may range from traffic filtering to full segment isolation. Finally, document the entire process and outcome for post-incident review and continuous improvement. Question 12. The risk matrix shows a critical vulnerability in east-west traffic flow between virtual machines within the same logical network segment, posing a significant threat of lateral movement for potential attackers. The organization operates a multi-tenant NSX data center environment with diverse application workloads and varying compliance requirements for each tenant. The design team is tasked with implementing a robust security solution to mitigate this risk without introducing significant latency or management complexity. Which approach best addresses this challenge? Option A. Rely on existing perimeter firewall rules to protect against east-west traffic threats, assuming internal threats are less likely. Option B. Deploy a single, high-capacity hardware firewall appliance at the core of the data center to inspect all east-west traffic between virtual machines. Option C. Implement NSX distributed firewall policies to enforce microsegmentation at the virtual machine network interface level, creating granular security policies based on workload identity and context. Option D. Configure extensive access control lists, ACL, on physical network switches to filter east-west traffic based on IP addresses and ports. The correct answer is C. Implement NSX distributed firewall policies to enforce microsegmentation at the virtual machine network interface level, creating granular security policies based on workload identity and context. Explanation. Scenario analysis. This scenario presents a common challenge in advanced network design, balancing the need for robust security controls with the operational requirements of a dynamic, multi-tenant environment. The risk matrix highlights a critical vulnerability in the east-west traffic flow, which is often the most challenging to secure effectively in modern data centers. The complexity arises from the need to implement granular microsegmentation without introducing excessive latency or management overhead, especially when dealing with diverse application workloads and varying compliance mandates across different tenants. The pressure to deliver a solution quickly, coupled with potential budget constraints, adds further layers of professional challenge, requiring careful consideration of technical feasibility, scalability, and long-term maintainability. Correct approach analysis. The correct approach leverages NSX's distributed firewall capabilities to enforce microsegmentation at the virtual machine VM or container network interface (VNIC) level. This aligns with the principle of least privilege, ensuring that only necessary communication paths are allowed between workloads. By applying security policies directly to the workloads, the solution effectively mitigates the east-west traffic risk identified in the matrix. This method is highly scalable and adaptable to dynamic environments, as policies follow the workloads regardless of their physical location or IP address. Furthermore, it minimizes the performance impact by processing firewall rules in the hypervisor kernel, reducing the need for dedicated hardware appliances and simplifying network architecture. This approach is best professional practice as it directly addresses the identified risk with a technically sound and operationally efficient solution, adhering to security best practices for modern cloud-native and virtualized environments. Incorrect approaches analysis. Implementing a perimeter-based firewall strategy for east-west traffic is an incorrect approach because it fails to address the core of the problem. Perimeter firewalls are designed for north-south traffic and are ineffective at inspecting or controlling traffic that originates and terminates within the data center. This leaves internal workloads vulnerable to lateral movement by attackers, directly contradicting the risk identified. Ethically and professionally, this represents a failure to implement appropriate controls for the identified threat. Relying solely on network access control lists, ACL, on physical switches is also an insufficient solution. While ACLs can provide basic filtering, they lack the granularity and dynamic policy management capabilities of NSX's distributed firewall. Managing ACLs across a large, multi-tenant environment becomes extremely complex and error-prone, increasing the likelihood of misconfigurations that could either create security gaps or disrupt legitimate traffic. This approach fails to meet the advanced security requirements for microsegmentation and is professionally inadequate for a modern data center. Deploying a single, large hardware firewall appliance to inspect all east-west traffic is another incorrect approach. This creates a significant performance bottleneck and a single point of failure. The sheer volume of east-west traffic in a virtualized environment would overwhelm such an appliance, leading to unacceptable latency and impacting application performance. Furthermore, it does not provide the granular, workload-centric security required for effective microsegmentation. Professionally, This demonstrates a misunderstanding of the traffic patterns and performance characteristics of virtualized data centers. Professional reasoning. Professionals should approach such scenarios by first thoroughly understanding the identified risks and their potential impact. This involves analyzing the risk matrix and correlating it with the specific network architecture and traffic flows. The next step is to evaluate potential solutions against established security principles, such as defense in depth and least privilege, and consider their operational implications, including scalability, manageability, and performance. When evaluating NSX capabilities, it's crucial to understand how its distributed nature and policy enforcement mechanisms can directly address the identified risks. A structured decision-making process involves 1. Risk assessment, 2. Requirement definition, security, performance, operational, 3. Solution exploration, leveraging platform capabilities, 4. Technical validation, and 5. Implementation and monitoring. This systematic approach ensures that the chosen solution is not only technically sound, but also aligns with business objectives and regulatory compliance. Question 13. The efficiency study reveals that certain application workloads are experiencing unacceptable latency within the NSX data center environment. Initial analysis suggests that the distributed firewall, DFW processing, might be contributing to this latency. Which of the following approaches represents the most professionally sound and secure method to address this performance degradation while maintaining robust security posture? Option A. Allocate additional CPU and memory resources to the NSX edge nodes and hypervisors hosting the affected workloads without further investigation into the DFW configuration. Option B. Conduct a detailed analysis of DFW rule sets and traffic flows to identify and optimize specific rules that are causing excessive processing overhead, potentially by refining rule logic or implementing more efficient matching mechanisms. Option C. Implement a network-wide exception to bypass the DFW for all traffic originating from or destined to the affected application segments to immediately alleviate latency. Option D. Deploy advanced security features such as intrusion detection/prevention, IDPS, across all NSX segments to enhance security, assuming this might indirectly improve traffic flow by preventing malicious activity. The correct answer is B. Conduct a detailed analysis of DFW rule sets and traffic flows to identify and optimize specific rules that are causing excessive processing overhead, potentially by refining rule logic or implementing more efficient matching mechanisms. Explanation. Scenario analysis. This scenario presents a common challenge in advanced network design, balancing performance optimization with the inherent complexities and potential security implications of advanced NSX features. The efficiency study highlights a performance bottleneck, but the proposed solution involves a feature that, while powerful, can introduce new attack vectors if not meticulously configured and managed. The professional challenge lies in identifying the root cause of the performance issue and selecting a solution that not only addresses the immediate problem, but also adheres to security best practices and the principle of least privilege, without introducing undue complexity or risk. The need for deep understanding of NSX's advanced capabilities and their security implications is paramount. Correct approach analysis. The correct approach involves a thorough investigation into the specific traffic patterns and application requirements that are contributing to the observed latency. This includes analyzing the behavior of the distributed firewall, DFW, and its rule sets, particularly any complex or overly permissive rules that might be impacting packet processing. By identifying and refining these DFW rules, the goal is to reduce the processing overhead on the NSX data plane, thereby improving performance. This approach aligns with best practices for network security and performance tuning, emphasizing granular control and the principle of least privilege. It avoids introducing new, potentially vulnerable features and instead optimizes existing configurations. This is professionally sound as it directly addresses the observed inefficiency through a controlled and secure method, minimizing the attack surface. Incorrect approaches analysis. Implementing a broad, network-wide exception for all traffic to bypass the DFW for performance reasons is a significant regulatory and ethical failure. This approach directly violates the principle of least privilege and introduces a massive security vulnerability by disabling a critical security control for all traffic. It would expose the entire network to potential threats that the DFW is designed to mitigate, leading to a severe breach of security and likely non-compliance with any security mandates or industry best practices. Enabling advanced security features like intrusion detection/prevention (IPS) or distributed intrusion prevention (DIP), without a clear understanding of their impact on performance and without a targeted deployment strategy is also problematic. While these features enhance security, their misconfiguration or indiscriminate application can lead to performance degradation, potentially exacerbating the very issue the efficiency study identified. Furthermore, deploying them without a clear security requirement or a phased rollout increases the risk of unintended consequences and operational complexity, deviating from a controlled and risk-managed approach. Simply increasing the resources, CPU/memory, allocated to the NSX edge nodes without a root cause analysis is a reactive and potentially wasteful approach. While it might temporarily alleviate the performance issue, it fails to address the underlying cause. This can lead to inefficient resource utilization and mask deeper configuration problems that could manifest later. It also bypasses the opportunity to optimize the existing configuration, which is a more sustainable and cost-effective solution. Professional reasoning. Professionals should approach such scenarios by first conducting a comprehensive root cause analysis. This involves detailed monitoring, logging, and traffic analysis to pinpoint the exact source of the performance bottleneck. Once identified, solutions should be evaluated based on their effectiveness, security implications, and adherence to the principle of least privilege. A phased implementation with thorough testing and validation is crucial. Professionals must prioritize solutions that optimize existing configurations before introducing new, complex features or simply throwing more resources at the problem. Regulatory compliance and ethical considerations, particularly regarding security and data protection, must be at the forefront of every design decision. Question 14. Cost-benefit analysis shows that implementing VMware NSX data center offers significant operational efficiencies and enhanced security capabilities for the organization's hybrid cloud environment. However, the organization operates under strict data privacy regulations and must maintain a robust audit trail for all network changes and security events. Given these constraints, which approach to NSX deployment best balances the benefits with the regulatory and security imperatives? Option A. Focus solely on deploying the core NSX functionalities that provide the most immediate cost savings, deferring advanced security features and comprehensive compliance validation until a later date. Option B. Deploy NSX across the entire environment as quickly as possible to realize the operational efficiencies and address security and compliance concerns in a subsequent, separate project. Option C. Implement NSX in phases, with each phase including thorough security validation, compliance checks against relevant regulations, and documentation of all configurations and events before proceeding to the next phase. Option D. Implement NSX using default configurations and rely on existing security tools to monitor for compliance issues, assuming that the vendor's best practices are sufficient. The correct answer is C. Implement NSX in phases, with each phase including thorough security validation, compliance checks against relevant regulations, and documentation of all configurations and events before proceeding to the next phase. Explanation. Scenario analysis. This scenario presents a common challenge in advanced network design, balancing the immediate benefits of a new technology with the long-term implications of its integration into a complex, regulated environment. The challenge lies in ensuring that the proposed solution, while offering clear advantages, does not inadvertently create compliance gaps or introduce unacceptable risks that could lead to regulatory scrutiny or operational disruption. The need for a robust security posture, adherence to data privacy principles, and the ability to demonstrate compliance to auditors are paramount. Correct approach analysis. The correct approach emphasizes a phased implementation strategy that includes comprehensive security validation and compliance verification at each stage. This aligns with best professional practices by prioritizing risk mitigation and ensuring that the NSX deployment adheres to established security policies and regulatory requirements from the outset. By integrating security and compliance checks into the design and deployment lifecycle, the organization can proactively identify and address potential issues, thereby minimizing the risk of non-compliance and ensuring a secure and auditable network infrastructure. This approach demonstrates due diligence and a commitment to responsible technology adoption. Incorrect approaches analysis, an approach that prioritizes rapid deployment without adequate security validation risks introducing vulnerabilities that could be exploited, leading to data breaches and regulatory penalties. This failure to conduct thorough security assessments before and during deployment is a direct contravention of principles of secure system design and potentially violates data protection regulations that mandate safeguarding sensitive information. Another incorrect approach would be to defer compliance checks until after the system is fully operational. This is a reactive rather than proactive stance. It significantly increases the likelihood of discovering compliance gaps late in the process, which can be costly and time-consuming to rectify. This can lead to fines, reputational damage, and a loss of trust from stakeholders, all of which are professionally unacceptable outcomes. A third incorrect approach might involve implementing NSX features without a clear understanding of their impact on existing compliance frameworks. This lack of foresight can lead to unintended consequences, such as the circumvention of existing security controls or the creation of new compliance burdens that were not anticipated. This demonstrates a failure in the design and planning phases, which are critical for ensuring that new technologies integrate seamlessly and compliantly. Professional reasoning. Professionals faced with such a decision should adopt a risk-based approach. This involves identifying potential risks associated with the proposed NSX deployment, assessing their likelihood and impact, and developing mitigation strategies. The decision-making process should be guided by a thorough understanding of the organization's regulatory obligations, security policies, and business objectives. A phased implementation with continuous validation of security and compliance is the most prudent path, ensuring that the benefits of the new technology are realized without compromising the integrity and compliance of the network. Question 15. What factors determine the optimal strategy for implementing NSX data center high availability and disaster recovery for a financial services organization with strict uptime and regulatory compliance requirements? Option A. The specific regulatory mandates for uptime and data recovery, the criticality of the services hosted on NSX, and the organization's tolerance for downtime and data loss. Option B. The ease of configuration and management of NSX features like distributed firewalling and load balancing. Option C. The availability of specific hardware vendors for network switches and servers. Option D. The number of NSX edge nodes required to support the expected network traffic load. The correct answer is A. The specific regulatory mandates for uptime and data recovery, the criticality of the services hosted on NSX, and the organization's tolerance for downtime and data loss. Explanation. Scenario analysis. This scenario presents a professional challenge in designing a highly available and resilient NSX data center deployment for a financial services organization. The core difficulty lies in balancing the stringent uptime requirements mandated by financial regulations with the inherent complexities of distributed systems and the potential for cascading failures. The organization's reliance on uninterrupted service for critical trading operations means that any design decision must prioritize fault tolerance and rapid recovery, while also adhering to specific compliance frameworks that govern data center operations and network security in the financial sector. Need to integrate advanced NSX features like distributed firewalling, load balancing, and microsegmentation adds layers of complexity, requiring a deep understanding of how these components interact under various failure conditions. Correct approach analysis. The correct approach involves a multifaceted strategy that prioritizes redundancy at every layer of the NSX infrastructure and the underlying physical and virtual compute resources. This includes deploying NSX managers in a highly available cluster, ensuring redundant transport nodes, SC hosts, or bare metal servers, and implementing robust network connectivity with multiple uplinks and redundant physical switches. For critical services, leveraging NSX's distributed load balancing with active-active configurations and health checks is paramount. Furthermore, a comprehensive disaster recovery plan that includes regular backups of NSX configuration and a well-defined procedure for failover and failback to a secondary site is essential. This approach aligns with regulatory expectations for business continuity and disaster recovery in the financial industry, which often mandates specific recovery time objectives, RTO, and recovery point objectives, RPO, that can only be met through such a resilient design. Adherence to these principles ensures minimal downtime and data loss, thereby maintaining regulatory compliance and business operations. Incorrect approaches analysis. One incorrect approach would be to focus solely on performance optimization without adequately addressing redundancy. This might involve consolidating NSX managers or transport nodes to reduce operational overhead, or neglecting to implement redundant network paths for management and data planes. Such a design would be highly vulnerable to single points of failure, directly contravening the uptime and resilience requirements of financial regulations. A failure in a single component could lead to extended service disruption, resulting in significant financial losses and regulatory penalties. Another incorrect approach would be to implement basic high availability for NSX managers, but fail to extend this redundancy to the underlying compute and network infrastructure. For instance, relying on a single physical network fabric or a single cluster of hypervisors for all NSX workloads would create a bottleneck and a critical failure point. Financial regulations often require a holistic view of resilience, encompassing not just the network virtualization layer, but also the entire data center stack. A third incorrect approach would be to overlook the importance of a well-tested disaster recovery plan. Relying on manual recovery procedures or inadequate backup strategies for NSX configurations would significantly increase the RTO in the event of a site-wide failure. This would be unacceptable for a financial institution, where even brief outages can have severe consequences, and would likely violate specific regulatory mandates regarding disaster preparedness. Professional reasoning. Professionals designing NSX data center solutions for regulated industries like finance must adopt a risk-based approach. This involves identifying critical business functions, understanding the regulatory landscape, and then designing a solution that mitigates identified risks to an acceptable level. The decision-making process should prioritize resilience, fault tolerance, and recoverability. This means thoroughly evaluating the impact of potential failures at each layer of the infrastructure and implementing appropriate countermeasures. Regular review and testing of the design, including failover and disaster recovery drills, are crucial to ensure that the implemented solution remains effective and compliant over time. Collaboration with compliance officers and business stakeholders is vital to ensure that the technical design meets both operational and regulatory objectives. Question 16. When evaluating advanced design options for VMware NSX data center to ensure regulatory compliance, which of the following approaches best integrates legal and compliance mandates into the technical architecture from the initial design phase? Option A. Proactively engage with legal and compliance teams to identify all relevant data protection and security regulations, and then design NSX policies and configurations to directly address these mandates, ensuring auditability and data integrity throughout the lifecycle. Option B. Focus on achieving the highest possible network throughput and lowest latency, assuming that standard security best practices within NSX will inherently satisfy most regulatory requirements without explicit verification. Option C. Prioritize the implementation of advanced security features and performance optimizations in NSX and address any regulatory concerns that arise during the operational phase through post-deployment configuration adjustments. Option D. Implement a comprehensive logging solution for all NSX traffic and events, and defer the detailed analysis of regulatory implications until a specific compliance audit is scheduled. The correct answer is C. Prioritize the implementation of advanced security features and performance optimizations in NSX and address any regulatory concerns that arise during the operational phase through post-deployment configuration adjustments. Explanation. This scenario presents a professional challenge in balancing the technical requirements of advanced network design with the imperative of regulatory compliance within the context of VMware NSX data center deployments. The core difficulty lies in ensuring that the chosen design, while optimized for performance and security, also adheres to specific data privacy and security regulations applicable to the organization's operating jurisdiction. A failure to integrate regulatory considerations from the outset can lead to costly redesigns, potential legal penalties, and reputational damage. Careful judgment is required to proactively identify relevant regulations and translate their mandates into concrete design decisions. The correct approach represents best professional practice because it embeds regulatory compliance as a foundational element of the design process. By engaging with legal and compliance teams early and continuously, the architect ensures that the NSX design actively supports adherence to data protection laws e.g., GDPR, CCPA, or equivalent within the exam-specified jurisdiction. This proactive stance minimizes risk and demonstrates a commitment to responsible technology deployment. Specifically, this involves understanding how NSX's microsegmentation, encryption, and logging capabilities can be leveraged to meet specific regulatory requirements for data access control, data in transit protection, and auditability. An incorrect approach that prioritizes solely technical performance without considering regulatory mandates is professionally unacceptable. Such an approach risks creating a system that, while technically sound, is non-compliant. This can lead to significant regulatory fines, mandatory system modifications, and potential business disruption. For instance, failing to implement appropriate data encryption for sensitive data flows, as might be mandated by a specific jurisdiction's data protection laws, would be a direct regulatory failure. Another failure would be neglecting to configure logging and auditing mechanisms to meet retention and access requirements stipulated by regulators, thereby hindering any necessary forensic investigations or compliance audits. The professional decision-making process for similar situations should involve a structured approach. 1. Identify all applicable regulatory frameworks based on the organization's industry and geographic locations. 2. Engage legal and compliance stakeholders to thoroughly understand the specific requirements and their implications for network architecture. 3. Map NSX capabilities to regulatory mandates, identifying areas where the technology can directly facilitate compliance and areas requiring specific configuration or policy implementation. 4. Integrate compliance checks and validation into the design and implementation phases, not as an afterthought. 5. Maintain ongoing awareness of evolving regulatory landscapes and adapt the NSX design and policies accordingly. Question 17. Risk assessment procedures indicate that the organization's current network segmentation strategy within its VMware NSX data center environment may not adequately address evolving regulatory compliance requirements for data protection and access control. Considering the need for granular security and auditability, which of the following approaches best aligns with advanced design principles and regulatory mandates for a secure and compliant NSX deployment? Option A. Design security policies primarily based on static IP address assignments for workloads, without deep consideration for application context or workload identity, to simplify initial deployment and management. Option B. Deactivate detailed security logging and auditing features within NSX to reduce the administrative overhead and complexity of managing security policies. Option C. Initially configure a broad, allow all distributed firewall policy for all network segments to ensure unimpeded application functionality, and plan to refine specific deny rules retrospectively as operational issues arise. Option D. Implement a default deny distributed firewall policy across all segments, followed by a phased, explicit allowance of traffic based on verified business needs and application dependencies, leveraging NSX's identity-aware controls and comprehensive logging. The correct answer is D. Implement a default deny distributed firewall policy across all segments, followed by a phased, explicit allowance of traffic based on verified business needs and application dependencies, leveraging NSX's identity-aware controls and comprehensive logging. Explanation. Scenario analysis. This scenario presents a professional challenge in balancing the need for advanced network segmentation and security controls within a VMware NSX data center environment, against the potential for operational complexity and the risk of misconfiguration. The core challenge lies in ensuring that the chosen security policy, while robust, does not inadvertently create compliance gaps or introduce vulnerabilities that could be exploited, thereby violating regulatory mandates. The rapid evolution of cloud-native applications and microservices further complicates this, demanding a security posture that is both granular and adaptable, while remaining auditable and compliant. Correct approach analysis. The correct approach involves a phased implementation of distributed firewall rules, starting with a default deny policy, and then incrementally allowing necessary traffic based on explicit business requirements and application dependencies. This aligns with best practices for network security and regulatory compliance by minimizing the attack surface from the outset. By adopting a least privilege principle, only essential communication paths are permitted, which directly supports compliance with regulations that mandate data protection and access control. This method ensures that any deviation from the intended security posture is immediately apparent and can be rectified, facilitating easier auditing and demonstrating due diligence to regulatory bodies. The use of NSX's microsegmentation capabilities to enforce these policies at the workload level is crucial for achieving granular control and meeting stringent compliance requirements for sensitive data. Incorrect approaches analysis. Implementing a broad allow all policy initially and then attempting to tighten it later is a significant regulatory and ethical failure. This approach creates an overly permissive environment, increasing the risk of unauthorized access and data breaches, which directly contravenes data protection regulations such as GDPR or CCPA, depending on the jurisdiction. Though for this exam, we focus on the principles of data protection as mandated by relevant frameworks. It also makes auditing extremely difficult, as it's hard to identify legitimate traffic versus malicious activity. Applying security policies based solely on IP addresses without considering the application context or workload identity is another failure. Many modern regulations require controls to be tied to the specific services and data being protected, not just network endpoints. Relying on IP addresses alone is brittle and prone to misconfiguration, especially in dynamic cloud environments, leading to potential compliance violations related to data segregation and access control. Disabling security logging and auditing features to simplify management is a critical regulatory failure. Compliance frameworks universally require robust logging and auditing to detect and investigate security incidents. Disabling these features prevents the organization from demonstrating adherence to security controls and responding effectively to breaches, leading to severe penalties and loss of trust. Professional reasoning. Professionals must adopt a risk-based approach to network security design. This involves understanding the regulatory landscape applicable to the data being processed and the services being offered. The design process should prioritize security by default, employing principles like least privilege and defense in depth. When implementing NSXD, a phased rollout with rigorous testing and validation at each stage is essential. Continuous monitoring, regular audits, and a clear change management process are vital to maintain compliance and adapt to evolving threats and regulatory requirements. The decision-making process should always weigh the potential security benefits against the operational impact and the risk of non-compliance, ensuring that security controls are both effective and auditable. Question 18. Stakeholder feedback indicates a desire to rapidly deploy advanced NSXT data center capabilities to enhance network agility and microsegmentation for critical applications. However, concerns have been raised regarding potential conflicts with the organization's adherence to the specified regulatory framework's data handling and privacy mandates. Which design approach best balances these competing priorities while ensuring strict regulatory compliance? Option A. Implement the most technically advanced NSXT features first to gain immediate operational benefits, and then seek guidance from the regulatory body on how to adapt the existing design to meet their requirements. Option B. Design the NSXT deployment with a primary focus on meeting all explicit regulatory requirements for data privacy, access control, and auditability, even if it necessitates a phased approach to advanced feature adoption. Option C. Focus on achieving the highest levels of network performance and scalability with NSXT, assuming that robust technical controls will inherently satisfy most regulatory data protection obligations. Option D. Prioritize the implementation of advanced NSXT features for maximum agility and microsegmentation, with a plan to address regulatory compliance requirements through post-deployment audits and remediation. Correct answer is D. Prioritize the implementation of advanced NSXT features for maximum agility and microsegmentation, with a plan to address regulatory compliance requirements through post-deployment audits and remediation. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid technological adoption and the need for robust regulatory compliance, particularly concerning data privacy and security. The organization is seeking to leverage advanced NSX features for agility, but this must be balanced against the stringent requirements of the specified regulatory framework. The core difficulty lies in ensuring that the design choices, while technically sound for performance and scalability, also meet the explicit mandates of the regulatory body regarding data handling, access controls, and auditability. The correct approach represents best professional practice because it prioritizes a comprehensive understanding and integration of regulatory requirements from the outset of the design process. This proactive stance ensures that the NSX deployment not only meets technical objectives, but also establishes a foundation for ongoing compliance. Specifically, it aligns with the regulatory principle of privacy by design and security by design, which mandates that compliance considerations are embedded into systems and processes from their inception. This approach minimizes the risk of costly retrofits, potential regulatory penalties, and reputational damage. It demonstrates a commitment to responsible innovation and adherence to legal obligations. An incorrect approach that focuses solely on technical performance without explicit regulatory validation fails to meet the organization's legal and ethical obligations. This would constitute a regulatory failure by potentially exposing sensitive data to unauthorized access or processing in a manner that contravenes data protection laws. Ethically, it represents a disregard for stakeholder trust and the organization's duty of care. Another incorrect approach that attempts to retroactively apply compliance measures after the design is finalized is also professionally unacceptable. This often leads to suboptimal solutions that may not fully address the regulatory intent, are more expensive to implement, and can introduce unforeseen operational complexities. It signifies a reactive rather than a proactive approach to compliance, increasing the likelihood of noncompliance and associated risks. The professional reasoning process for similar situations should involve a structured risk assessment that explicitly maps technical design elements to specific regulatory mandates. This includes engaging with legal and compliance teams early and continuously throughout the design lifecycle. A thorough review of the regulatory framework's requirements for data segmentation, encryption, logging, and access control should inform every architectural decision. When evaluating design options, professionals must ask, does this design choice demonstrably satisfy the relevant regulatory clauses? And can this satisfaction be objectively verified through audit trails and system configurations? This systematic approach ensures that technical innovation is always underpinned by a solid framework of regulatory adherence. Question 19. Cost-benefit analysis shows that implementing advanced security features within VMware NSX data center is a strategic imperative for meeting evolving regulatory compliance requirements. Given a hypothetical regulatory framework that mandates strict data segregation for sensitive customer information and comprehensive audit trails for all network access, which NSX design approach best aligns with these compliance objectives while remaining cost-effective? Option A. Prioritize the implementation of advanced threat prevention features in NSX, assuming this implicitly covers all regulatory data segregation and audit requirements. Option B. Deploy NSX with extensive, overly broad firewall rules across all segments to ensure maximum security, without specific consideration for data segregation mandates. Option C. Implement a flat network architecture with minimal firewalling to reduce complexity and operational costs, relying on host-based security for compliance. Option D. Design a micro-segmented network using NSX security groups and distributed firewall rules to isolate sensitive data segments, coupled with centralized logging of all NSX events to a SIEM for audit purposes. Correct answer is D. Design a micro-segmented network using NSX security groups and distributed firewall rules to isolate sensitive data segments, coupled with centralized logging of all NSX events to a SIEM for audit purposes. Explanation. This scenario presents a common challenge in advanced network design, balancing the need for robust security and compliance with the practicalities of implementation and operational overhead. The professional challenge lies in interpreting and applying the VMware NSX data center regulatory framework, which, for the purpose of this exam, is assumed to be aligned with the specific compliance mandates relevant to the exam's jurisdiction, e.g., a hypothetical National Data Protection Act or industry-specific security standard. The core difficulty is ensuring that the chosen NSXT design not only meets the technical requirements for advanced security features, but also adheres to the spirit and letter of these regulations, particularly concerning data privacy, access control, and auditability, without introducing undue complexity or cost that would undermine the initial cost-benefit analysis. The correct approach represents best professional practice because it prioritizes a comprehensive understanding of the regulatory landscape and its direct implications for NSXT design. This involves a proactive engagement with compliance teams to translate abstract regulatory requirements into concrete technical controls within NSXT. For instance, if a regulation mandates granular access control to sensitive data, the design must incorporate NSXT's microsegmentation capabilities and role-based access control, RBAC, to enforce these policies at the network level. Furthermore, ensuring comprehensive logging and auditing capabilities within NSXT is crucial for demonstrating compliance and facilitating incident response, aligning with regulatory expectations for accountability and transparency. This approach ensures that security and compliance are not afterthoughts, but are integrated into the design from the outset, leading to a more secure, compliant, and maintainable infrastructure. An incorrect approach that focuses solely on implementing the most advanced security features of NSXT without a clear mapping to specific regulatory mandates is professionally unacceptable. This could lead to over-engineering, increased complexity, and potentially misaligned controls that do not adequately address the actual compliance risks. For example, implementing extensive firewall rules without understanding which specific data flows or network segments are subject to regulatory scrutiny might be technically sound, but regulatorily insufficient or even counterproductive if it hinders necessary auditing. Another incorrect approach might be to prioritize cost savings by omitting certain NSXT security features that are implicitly or explicitly required by regulations, such as advanced threat prevention or detailed logging. This failure to adequately provision for compliance requirements can result in significant penalties, reputational damage, and a lack of demonstrable adherence to legal obligations. The professional decision-making process should involve a structured approach. First, thoroughly understand the applicable regulatory framework and identify all relevant requirements. Second, translate these requirements into specific NSXT design considerations and technical controls. Third, conduct a thorough risk assessment to prioritize controls and ensure that the design effectively mitigates identified compliance risks. Finally, engage in continuous validation and auditing to ensure ongoing adherence to both technical design and regulatory mandates. Question 20. The monitoring system demonstrates a configuration that captures detailed audit logs for all NSXT components, including every packet flow and API call, without any aggregation or filtering, across all network segments. Which of the following approaches best aligns with the principles of efficient and compliant advanced network monitoring in a VMware NSXT data center environment? Option A. Enable verbose logging for all NSXT components and events without any filtering or aggregation to ensure maximum data capture for potential future analysis. Option B. Configure NSXT to send only high-level system status messages to an external log aggregation tool, assuming it can infer detailed event information. Option C. Implement a tiered logging strategy that prioritizes critical security events and operational anomalies, with selective capture of other data for specific troubleshooting or audit purposes. Option D. Disable logging for all but the most basic system health checks to maximize network performance and minimize storage requirements. The correct answer is C. Implement a tiered logging strategy that prioritizes critical security events and operational anomalies, with selective capture of other data for specific troubleshooting or audit purposes. Explanation. Scenario analysis. This scenario presents a common challenge in advanced network design, balancing the need for granular visibility and security logging with the potential for performance degradation and the complexity of managing vast amounts of data. The professional challenge lies in identifying a monitoring strategy that is both effective for regulatory compliance and operationally sustainable within the constraints of a VMware NSXT data center environment. The specific regulatory framework for this exam, 3V0-42, 20 Advanced Design VMware NSX Data Center, implies a focus on security, operational integrity, and potentially data privacy as dictated by relevant, albeit unspecified, governing bodies for such advanced deployments. The difficulty arises from the need to interpret and apply these abstract requirements to concrete technical decisions, ensuring that the chosen monitoring approach meets both technical and compliance objectives without introducing undue risk or overhead. Correct approach analysis. The correct approach involves a tiered logging strategy that prioritizes critical security events and operational anomalies, while selectively capturing less critical data for specific troubleshooting or audit purposes. This aligns with best practices for efficient log management and regulatory compliance. By focusing on high-fidelity events, e.g., security policy violations, unauthorized access attempts, significant network disruptions, the system ensures that compliance mandates for audit trails and incident response are met. The selective capture of other data, perhaps through sampling or event-driven logging, mitigates performance impact and storage costs. This approach demonstrates professional judgment by acknowledging the trade-offs between comprehensive data collection and operational feasibility, ensuring that the monitoring system is a valuable tool rather than a burden. It implicitly adheres to principles of proportionality and necessity often found in regulatory frameworks, where the scope of data collection should be commensurate with the risks being managed and the compliance obligations. Incorrect approach is analysis. One incorrect approach is to enable verbose logging for all NSX components and events without any filtering or aggregation. This would generate an overwhelming volume of data, making it difficult to identify critical security events or operational issues. From a regulatory perspective, this approach fails to demonstrate efficient resource management and could lead to missed critical alerts, thereby compromising compliance with incident detection and response requirements. It also introduces significant performance overhead, potentially impacting the very network operations it's meant to monitor, which is an ethical failure in ensuring system stability. Another incorrect approach is to disable logging for all but the most basic system health checks. While this would maximize performance and minimize storage, it would leave the organization blind to security threats and operational anomalies. This is a direct violation of most regulatory frameworks that mandate comprehensive audit trails for security events and network activity. It represents a failure to uphold professional responsibility for security and operational integrity, creating a significant compliance and risk management gap. A third incorrect approach is to rely solely on external log aggregation tools without configuring NSX to send specific, relevant logs. This assumes that external tools can magically infer all necessary information, which is rarely the case. NSX's internal logging mechanisms are designed to capture specific events and states crucial for security and operations. Failing to configure the source to send the right data means the aggregation tool will be incomplete, leading to gaps in audit trails and an inability to meet compliance requirements for detailed event logging. This demonstrates a lack of understanding of the NSX architecture and its logging capabilities, leading to a technically deficient and non-compliant monitoring solution. Professional reasoning. Professionals should approach monitoring system design by first understanding the specific regulatory and compliance obligations applicable to their organization and the data being handled. This involves identifying what events need to be logged, for how long, and in what detail. Subsequently, they must assess the technical capabilities of the NSX data center environment, including its logging features, and the potential impact of logging on performance. The decision-making process should then involve designing a tiered logging strategy that prioritizes critical security and operational events, while employing efficient data management techniques for less critical information. This iterative process of understanding requirements, assessing capabilities, and designing for efficiency and compliance ensures that the monitoring system is effective, sustainable, and defensible from a regulatory standpoint.